Okay, resume tayo. May nakalimutan na akong ano, i-discuss. Yeah. By the way, nakalimutan ko, may isa pa pala tayong equation dito. Shear max is equal to yung principal stress 1 minus principal stress 2 all over 2. Okay. So, yan yung equation natin for maximum shear. Sige. Proceed tayo sa sample problem number 1 natin. That is sample problem 925. Kung meron kayong mga books, yung green na book na um, sinuggest ko sa inyo, problem 925. So we have two wooden joists, 50 millimeters by 100 millimeters, are glued together along the joint AB as shown in this figure. So meron tayong joist 1, joist 2, tapos pinagdikit lang siya using glue, wood glue. Okay? So determine the normal stress and shearing stress in the glue if P is equal to 200 kilonewtons. So we have answer that is 16.5 megapascal. Hindi ko natanggal. So dapat wala yan. Tanggalin ko lang. Spoiler alert, mapapansin na agad na mali yung sagot natin sa una. Sige. Okay. So kunwari hindi niyo nakita yung answer na 16.5 megapascal. So ayun nga, we have a wooden joist, two wooden joists na pinagdikit using glue. Tapos kinargahan natin ng P that is 200 kilonewtons. So we will compute yung normal stress tsaka shearing stress along plane AB kung saan natin pinagdikit yung wooden joist natin. And ito yung general na yung general na rule natin or general concept sa pagso-solve ng mga structures kung saan halimbawa wineld lang natin yung dalawang structure. So i-analyze natin yung plane or yung area kung saan natin pinagkabit yung dalawang member. For example, dalawang bakal na pinag-weld natin, di ba? So i-analyze natin siya doon sa sa part kung saan natin wineld yung ating dalawang bakal. So ganun lang din yung dito kasi doon yung yung critical na stresses. So doon most probably magkakaroon ng failure kasi. So sige, dito tayo sa sa sample problem natin. So we have plane AB that is inclined 40 degrees from the horizontal. So first order of of solution natin ay i-draw natin yung stress element natin. So, para ma-draw natin yung stress element, kukuha tayo ng maliit na element, tapos ilalagay natin yung mga loadings sa ating system. So, we have P to the right, P to the left. Tapos, ang hinahanap natin ay yung stresses along the inclined plane 40 degrees from the horizontal. By the way, yung horizontal axis natin would be X, vertical axis natin would be Y. Now, moving forward, yung equation natin for normal stress tsaka shear stress, kailangan natin ng stress X tsaka stress Y. Tapos yung theta. So, meron naman tayong angle, di ba? So, okay na tayo dyan. Kailangan lang natin yung stress X kasi yung given dito sa problem natin is P, 200 kilonewtons, and kilonewtons is a unit of force. So, dapat kailangan mo natin i-convert into stress, which is megapascal, and so on and so forth. Okay, basta dapat unit natin ay stress. So, next step natin should be finding the stresses along X and stresses along Y. So, kailangan lang natin hanapin yung mga variables na kulang dito sa ating equation. So, stress along X, that would be P over A. So, yung P natin, that is 200 kilonewtons. Yun yung kinarga natin na loading. And then, yung area kung saan siya nakakabit ay yung area or yung cross-section ng ating wooden joist. Okay? So, meron tayo sa given natin, that is 50 millimeters by 100 millimeters. Yan yung cross-section ng ating wooden joist. So, yan na yung gagamitin natin na area. Area is equal to 50 millimeters times 100 millimeters. So, this will give us a value for stress along X direction na 40 megapascal. So, ito na yung stress X natin, 40 megapascal. And then, stress along Y natin, dito sa ating stress element, tignan natin. So, sa stress element natin, meron ba tayong loading sa ating Y direction? So, wala tayong nakikita, di ba? So, therefore, yung stress along Y natin ay 0. So, ganun lang hanapin yung mga stresses. No? Kung forces, kailangan mo muna i-divide into area. Pagka stress, pwede mo na i-direct substitution sa equation natin. By the way, nakuha na natin yung stress along X. nakuha na natin yung stress along y, we can now proceed sa pag-solve ng normal stress tsaka shear stress. So, ito yung given natin. Stress x is equal to 40 megapascal. Stress y is equal to 0. And theta is equal to 40 degrees. Tapos yung shear xy natin, that is equal to 0. Okay? So, let us find the normal stress at 40 degree incline. So, we have stress x prime, that is stress x. Ito yung equation natin. Meron tayo yung mga variables. Check na tayo sa stress x. Meron na tayo stress y, meron tayong theta. Substitute na lang natin. Okay? So, 40 megapascal plus 0 megapascal all over 2 plus 40 megapascal minus 0 megapascal all over 2 cosine 240 degrees plus dahil nga 0 yung shear stress natin, pwede na nating neglect or i-cancel out ito. Okay? So, that is yung equation natin. Pinrin sa calculators natin, makukuha natin yung sagot na 23.473 megapascal. So, as you can see dun sa problem natin kanina, yung answer natin for stress, that is 16.5 megapascal, di ba? Obviously, itong sagot na to ay mali. Okay? So, mali itong sagot na to in the sense na yung ginamit natin na theta ay 40 degrees. So, balikan natin yung discussion natin kanina. Yung theta na kino-consider natin para makuha itong equation na ito is this theta right here. Yung nasa tuktok ng ating triangle. Okay? That is why, dito sa stress element natin, ang theta dapat na gagamitin natin ay hindi 40 degrees, kundi 50 degrees. Yung nasa tuktok ng ating triangle. So, parang naka-mirror lang siya dyan. Diba? So, kaya yung theta dapat natin, hindi siya 40 degrees. It should be 50 degrees. Okay? So, paano naging 50 degrees? Basic geometry na lang yan. Dapat alam niyo na yan. Okay? So, dapat yung theta natin 50 degrees. So, ulitin natin yung solution natin. This time, using yung theta as 50 degrees. So, substituting the values. So, we have 40 megapascal plus 0 megapascal over 2 plus 40 minus 0 over 2 times cosine 2 theta 50 degrees plus 0 sine 2 50 degrees. Dahil nga 0 yung shear stress natin, we can disregard this part right here. Tapos, pinutin na sa calculators natin, we will get the value 16.527 megapascal. This will now be yung normal stress natin at the glue. At the plane kung saan natin pinagdikit yung ating wooden joist. Okay? So, are there any confusions or questions? Or do you have, what questions do you have regarding this solution? So far, wala pa naman. Basic substitution lang to. Ang kailangan lang nating maging careful is determining the value of theta. Okay? So, moving on. Tapos na tayo sa normal stress. Hanapin na natin yung shearing stress in the glue. So, shear stress at 40 degree incline. Okay na tayo sa theta. Tama na yung theta na ginamit natin. So, we can proceed sa equation natin. That is equal to negative stress x minus stress y over 2 sine 2 theta plus shear xy cosine 2 theta. Okay, so we have negative 40 megapascal minus 0 megapascal over 2. Sinubstitute ko lang yung mga values. Okay, and then, yan sa calculators natin, then we have negative 19.6962 megapascal. So, this will now be yung shear stress natin in the glue. Sige, process nyo muna sa calculators nyo. Tignan nyo. Check nyo kung tama yung mga values na nakuha natin. Okay na? Let's proceed. Okay, very basic pa lang to, madali pa lang. By the way, balikan muna natin yung equation, equation ng maximum shearing stress. Meron kasi tayong dalawang equation for maximum shearing stress, di ba? So kung mapapansin natin, yung first part, yung maximum shearing stress dito sa first part, that is in terms of stress X, tsaka stress Y, tsaka shear XY. Dito naman sa pangalawang equation natin, pag nakuha na natin yung mga principal stresses, stress 1 tsaka stress 2, we can directly solve for the maximum shear. Okay? So, depende na din kung ano yung mga given sa ating problem. You can use one of the two equations. Okay? So, yun lang yung general note regarding that. Okay? So, moving forward sa ating sample problems. So we have sample problem 926. So this particular problem mas na siya, medyo combined loading na siya. Kung saan meron tayong normal stress along X, meron tayong normal stress along Y, tapos meron din tayong shearing stress. Okay? So sige, proceed tayo. Ganun, yung ano. Okay. Sige. Proceed tayo sa solution natin. So, here we can see yung mga loadings natin ay stresses na siya. No? Kaya wala na tayong kailangang i-convert. So, we can go directly sa ating solution. By the way, if the element is subjected to the state of stress shown in the figure, we are asked to find the principal stresses. Okay? So, first let us find yung major principal stresses natin. The equation natin for major principal stress, that is equal to stress x plus stress y over 2 plus square root of stress x minus stress y squared plus 4 shear stress xy squared all over 2. Now, before tayo mag-input, kailangan muna natin i-consider yung mga nature ng stresses natin. Is it compressive or tensile? So, yung general rule natin na positive ang tension, negative ang compression, it applies the same. Kasi sa mga considerations natin kanina nung sinolve natin itong mga equations na ito, yung mga stresses natin or yung mga forces natin, they are considered as tensile. So, positive siya. So, pagka yung forces natin or yung stresses natin ay compressive, we will consider that as negative, as shown in this example. So, yung stress X natin, that is 4,000 PSI, it is in tension. So, it should be positive. Yung stress Y naman natin, it is 8,000 PSI, it is in compression. So, dapat negative siya. Kaya dito sa equation natin, yun na yung kailangan nating baguhin sa ating mga input. Pag tension, positive. Pag compression, negative. So, we have stress X, that is 4,000 PSI, plus negative 8,000 PSI all over 2, plus square root of yung stress X natin na 4,000, minus stress Y natin na negative 8,000 PSI. Tapos, squared natin yan, plus 4 times yung shear stress natin na 6,000 PSI squared. So, sa shear stress naman, hindi na natin kailangan i-consider kung negative o positive because i-square naman natin siya. But para ma-determine lang natin kung positive o negative yung shear stress natin, titignan natin yung, by the way, hindi naman pala important yung sign ng shear stress dito sa equations natin. Ayun yung sinasabi ko kasi mag-i-square naman natin, so mag-cancel out na siya. Okay? So, ganun lang kasi sa Morse circle, very important na yung sign ng natin ng shear stress natin. So later na natin i-discuss yun, yung sign ng natin ng shear stress natin. So as of now, wag muna natin i-consider yung sign ng shear stress natin. Okay? So solving sa calculators natin, we can get yung value for major principal stress natin na paki-pindot sa calculators nyo tapos send nyo sa chat. Ano yung nakuha niyo? Sigurado ba yan? Testing ko din, ano? The answer should be 6,485.2814 PSI. Check ko lang din, ano? Kasi iba din yung nakuha niya eh. Negative 8,000. Consider niyo yung mga signs. Square root of, or yung mga grouping nyo. Minus negative 8,000. 4 times 6,000 squared or over 6,485.2184 PSI. So, yun yung makukuha nyo na sagot. So, this is now yung major principal stress natin. Okay? So, paki-check na lang sa sa mga notes nyo later on kung kung saan kayo nagkamali sa calculators nyo. But this would be yung sagot natin. Thank you for responding. 6,485.2814 PSI. And syempre, after that, we can solve for the minor principal stresses. So we have stress 2 is equal to, yun lang, papalitan lang natin yung sign na to into negative. Right? So, ganoon lang. Pag tama na yung sa calculators nyo, masasolve nyo na yung minor principal stresses. Gagawin nyo lang negative yung sign sa pagitan ng dalawang term. So, substituting the values, so we have 4,000 plus negative 8,000 all over 2, negative square root of 4,000 minus 8 minus negative 8,000, quantity squared plus 4, 6,000 squared all over 2. So, yung may sagot natin for the minor principal stress should be pakisend ulit sa chat. Negative 10,485 tapos copy paste na lang Ayan, so that would be yung minor principal stress natin, that is negative 10,485.2814 PSI. So, ibig sabihin yung stress to natin, hindi siya tensile, kundi compressive. Diba? So, that is yung natin, so major principal stress, tsaka minor principal stress natin. Okay? Ano pa yung mga kailangan nating hanapin? Yung maximum shear. Mga possible na pwede nating hanapin for this particular problem is yung maximum shear natin. Ano ba yung maximum shearing stress sa ating mga principal planes? So, para mahanap natin yung maximum shear, pwede natin gamitin yung equation 1 tsaka equation 2. Di ba, dalawa yun, yung using yung stress x, stress y, tsaka yung other equation naman using principal stress 1 tsaka principal stress 2. So, in this particular, gagamitin na lang natin yung mga principal stress na na-solve natin. Bakit positive? Ay, tama. Tama lang. So, maximum shear is equal to stress 1 minus stress 2 all over 2. Na yung major principal stress natin, that is 6,485.28 PSI minus negative 10,485.2814. Dahil nga negative, negative yung original na sign natin, negative times negative, that would be positive. Okay? And then all over 2 lang. So, using this equation, makukuha natin yung maximum shear to be 8,485.2814 PSI. So, that is yung maximum shear that may occur sa ating dito sa ating principal, ay sa ating stress element. Okay? That would be yung maximum shear. Okay? So, let it, i-process nyo muna before we move on sa ating, solution. Okay. So, na-solve na natin yung mga principal stresses. Okay na tayo sa problem na ito. Before we proceed, gusto ko lang ipakita yung mga other possible na pwede kong ipahanap sa inyo sa inyong mga exam. So, yun nga, nahanap na natin yung mga principal stresses. So, principal stress 1, that is 6485.2814 psi. Minor principal stress, that is negative 10K. Tapos yung maximum shear, that is 8,000. May mga possible na pwede pa tayong hanapin dito. For example, what is the location of the principal plane? So para mahanap natin yung location ng principal plane, meron tayong equation. So we have theta p1, that is 1 half tan negative 1 at arctan of 2 times shear xy all over stress x minus stress y. So that is yung equation natin for the first principal plane. And pag assumption natin mga given, so that is 2 times 1 half of arctan 2 times 6,000 all over 4 minus negative 8,000. And this is in PSI. So magka-cancel out na yung mga units. So unitless itong factor na ito. Tapos perform lang natin yung operation. Makukuha natin yung value na theta na. Paki-send ulit sa chat. So we have 1 half of arctan 2 times 6,000. Tama, for 22.5 ang ano natin. So we have yung theta natin or yung location ng principal plane natin or yung major principal stress natin, that would be 22.5 degrees. So yan yung plane kung saan magkakaroon tayo ng maximum ng major principal stresses. So yung rotation na yan basing dun sa analysis natin kanina would be this inclination right here. Yung theta na yan that is measured counterclockwise or clockwise, pwede na din, or clockwise from the vertical face ng ating stress element. Okay? So that is 22.5 degrees. Okay? So that is yung for major principal stress. For minor principal stress naman, si stress 2, makikita natin yan dito sa equation number 2 natin in finding the location of the principal plane. So we have theta P2, that is equal to theta P1 plus 90 degrees. So 22.5 plus 90, that is simply 112.5. That is yung location ng ating minor principal plane or minor principal stress. Okay? So 112.5 degrees. Okay? And again, yung rotation niya ay from the vertical face of the stress element. So from this, iikot siya hanggang ma-reach niya yung 112.5 degrees. So yung magiging itsura ng plane natin ay para magiging ganito na siya. Diyan natin makikita yung principal stress 2. Tapos yung stress 1 natin ay dito. Okay? Let it sink in. So madali lang. Using the equations lang naman yan. Tapos determining kung negative o positive lang ba yung mga stresses. So another thing na pwede kong ipahanap sa inyo ay yung corresponding normal stresses. So what is the corresponding normal stress? So the corresponding normal stress is simply the average normal stresses applied on all 4 faces. So we have 4 faces dito, di ba? Meron tayong dalawang 8K na compressive, so negative 16K. Tapos meron tayong dalawang 4K na tension, so we have 8,000 PSI. So kunin lang natin yung average ng mga stresses na yan. So therefore, stress X plus stress Y all over 2, that is equal to 4,000 plus negative 8K all over 2. and we will get yung average stress na negative 2,000 PSI. Okay. So, yun lang. Very basic. Pag corresponding normal stress, it is just the average normal stress on all four spaces ng ating stress element. And lastly, dahil nga kanina may nakuha tayong maximum shearing stress, di ba? Siyempre, may part din na kailangan nating hanapin or may point din kung kailangan nating hanapin yung location ng maximum shearing stress. So, para mahanap natin yung location of maximum in-plane shear stress, gagamitin din yung equation natin na theta S is equal to 1/2 tan minus 1 negative stress X minus stress Y all over 2 times shear XY. And then substituting the values, so we have 1/2 arctan of 4,000 minus negative 8,000 all over 2 times 6,000. We will get yung theta or yung location ng maximum shear stress to be negative 22.5 degrees. Okay? Please confirm kung parehas tayo ng nakuhang angle. Okay? So, tama. So, negative 22.5 degrees. So, yung magiging rotation niya, kung yung mga principal stresses natin, nag-rotate tayo ng counterclockwise from the vertical face ng ating stress element, dito mag-rotate tayo ng clockwise naman na 22.5. So, negative 22.5 ay pagganito na siya. So, dyan natin matatagpuan or dyan natin makukuha yung maximum shear stress natin given the loadings sa ating stress element. Okay? So, let it sink in before we go sa ating summary. Okay? So, summarizing yung mga nakuha nating values, so yung mga principal stresses natin, tapos yung corresponding location natin. So, for our major principal stress, yung nakuha nating value ay 6,485.2814 PSI. Tapos yung location niya ay 22.5 degrees from the vertical axis of the stress element. Tapos for our minor principal stresses, stress 2 is equal to negative 10K, 485.2814 PSI. Tapos yung location niya, that is 112.5 degrees from the vertical axis of our stress element. At syempre, meron yung nakuha nating shear max, that is equal to 8,485.2814 PSI. Tapos yung location niya ay negative 22.5 degrees from the vertical face of our stress element. Okay? And yung corresponding normal stress natin, that is 4,000 minus 8,000 all over 2, and that would give us negative 2,000 PSI. So, yung corresponding normal stress, again, that is simply the average stress on all four faces ng ating stress element. And lastly, siguro pwede natin itong gawing checking. So, given the location of the principal planes, we can check if the solved theta values will give the corresponding principal stresses using the general formula for shear and normal stresses below. So, kung maalala natin, yung equations natin for shear stress at saka normal stress for any inclined plane ay given sa equation na ito. Okay? So, i-check natin yung pag i-check natin yung principal stresses, yung mga theta values na ito, halimbawa sa ating major principal stresses, yung 22.5, pag gagamitin natin yan dito sa ating equation for stress X prime, dapat yung makukuha nating sagot ay 6,485.2814 PSI. So, paki-check naman sa calculators natin kung parehas tayo ng makukuha. Okay, calculator. Stress X natin ay 4,000 plus stress Y natin ay negative 8,000 all over 2 plus stress X na 4,000 minus 8,000 all over 2 cosine 2 theta. Yung theta natin ay 22.5 degrees plus yung shear stress natin na 6,000 psi times sine 2 theta. Again, yung theta natin 32.5. Same lang ba na nakuha? 6485.2814 psi. So, parehas lang sila na nakukuha. Okay. So, ibig sabihin, tama yung theta na nakuha natin dito. At you can do the same for the corresponding value of theta at saka stresses. Okay? Paki-check na lang sa notes niyo kung parehas kayo ng nakuha. Pag ito mga thetas na ito, i-substitute nyo dito sa equations natin. Okay? Dapat yung corresponding na stresses na makukuha nyo ay ito. Okay. So, that sums up our discussion for sample problem 926. So, next problem tayo. Let it sink in yung mga diniscuss natin muna bago tayo mag-proceed. Okay, proceed tayo. Last sample problem for the day. So we have sample problem 934. So we have a small block, 1.6 inches long and 1.2 inches high. Tapos yung thickness niya ay 0.2 inches thick. It is subjected to uniformly distributed tensile forces having the resultant values as shown in this figure. So yung mga loadings natin ay mga forces pa lang. So ang first step natin, i-convert natin siya into stresses. So, we are asked to compute the stress components. Hanapin natin yung stress components developed along the diagonal AB. So, yung diagonal na yon would be this diagonal dito sa ating figure. So, this is now our stress element. So, yun nga yung sinasabi ko kanina, yung mga loadings natin ay forces pa lang. So, dapat i-convert natin siya into stresses. So, the applied stresses, so stress along X, that is equal to P over A. Yung loading natin ay 2,400 pounds. Tapos yung cross-sectional area, kung saan siya nakakabit would be this area right here. Where, nakalagay naman dito sa ating problem yung mga dimensions ng ating block. So yung block natin, yung height niya ay 1.2, tapos yung base niya ay 1.6 inches. Tapos may thickness siya na 0.2 inches. So, ibig sabihin, yung dimension na ito would be 1.2. Tapos, multiply natin sa thickness na 0.2 inches. So, that would be yung area na nagsusupport sa ating 2,400 pounds na load. So, therefore, yung area natin dito, that would be 1.2 inches times yung thickness na 0.2 inches. Okay? So, that would give us an equivalent of 10,000 pounds per square inch. So, that would be yung stress along X direction natin. Now, let us solve for the stress along Y direction. Same process lang. P over A. Tapos yung loading natin na 1 to 80 pounds all over 1.6 inches times yung thickness na 0.2 inches. Again, 1.6 yung ginamit natin kasi yung cross-sectional area na bumubuhat sa 1.280 kips natin ay itong cross-section na ito. So therefore, yung area natin would be 1.6 yung dimension nito times yung thickness ng ating block. So we will get yung stress along y direction natin to be 4,000 psi. Okay, so this is now yung applied stress natin for stress y. And then, yung equation natin, we have stress x. Check na tayo sa stress x. Meron na tayong stress y. Tapos, hahanapin na lang natin yung theta. And again, yung theta na i-consider dapat natin ay itong theta na ito. So, isolating yung triangle na ito, we have made a triangle with the base 1.2 tsaka 1.6. I-isolate natin yan. Ito na yung magiging figure natin. We can now solve for theta using simple trigonometric functions. So we have sine theta is equal to 1.6 over 2, or that is equal to getting a value for theta, makukuha natin yung 53.13 degrees. At ganoon din, pwede yun din gamitin yung cosine theta. Wala namang maling approach. Basta tama yung process nyo. So cosine theta, that is adjacent over hypotenuse. So, pag ito yung theta natin, yung adjacent side natin would be 1.2, tapos yung hypotenuse natin ay 2. So, we have 1.2 over 2. Getting a value for theta, we will get the value 53.13 degrees. Hindi to sarado, may katuloy pa ito. So, kung ito yung gagamitin nyo sa solutions nyo, i-store nyo muna to sa mga calculators nyo. So, i-store nyo sa A, sa B, sa E, sa F, hanggang maubos yung, yung storage nyo. Okay. So, this will be yung values ng theta natin. Okay na tayo. Meron tayong theta, stress F, stress Y. Pwede nating ibato sa ating, or i-substitute sa ating equations directly. Wala nang kailangan na conversion required. So, you will get the correct answer. But in this particular solution, I will use yung trigonometric identities. Okay. So, maganda din na ina-exercise natin yung mga basic na fundamentals natin sa trigon natin, especially yung identities. So, we have cosine 2 theta tsaka sine 2 theta. Hanapin muna natin yung equivalent value ng mga yan. Okay? By using trigonometric identities, ito yung mga nakuha natin, stress x natin, 10k psi, tapos stress y natin, that would be 4k psi. We have sine theta, that is 1.6 over 2. Tsaka yung cosine theta natin, that is 1.2 all over 2. That is adjacent over hypotenuse lang. Tapos yung sine theta, that is opposite over hypotenuse. Okay. So katawa, yun lang yan. Okay. And then yung trigonometric identities natin, so we have sine 2 theta, that is equal to 2 sine theta, cosine theta. Substituting the values for sine theta tsaka cosine theta, we have 2 times 1.6 over 2 times 1.2 over 2. Tapos getting a value for sine 2 theta, makukuha natin yung sagot na 24 over 25. So yan ang equivalent ni sine 2 theta. And after that, getting a value for cosine 2 theta, that is just equal to cosine squared theta minus sine squared theta. Okay? Yung value ni cosine theta, that is 1.2 over 2. So 1.2 over 2 squared minus yung value ni sine theta na 1.6 over 2 squared. Simplifying, we get yung value ng cosine 2 theta na negative 7.25. So, ito na yung mga values ng sine 2 theta, cosine 2 theta. We can now substitute sa ating equation. So, we have stress x prime. Meron tayong cosine 2 theta dito, meron tayong sine 2 theta dito. So, yun yung mga iano lang natin. So, stress x natin, 10k psi, plus stress y natin 4k psi. By the way, lahat tension kaya walang negative tayo na ilalagay dito sa ating mga input. So 10k plus 4k over 2 plus 10k minus 4k over 2 times yung cosine 2 theta na equivalent niya. Cosine 2 theta negative 7 over 25. So yun na ilalagay ko dito. And then, shear stress, wala naman tayong given na shear stress. So 0 lang siya. So, itong term na ito, makaka-cancel out na lang siya. Okay, so shear stress, cancelled out lang yan. That would be 0. Kaya yung value ng stress x natin would be, you would get the value 6,160 PSI. So this is now yung stress natin or yung normal stress on the plane on this diagonal plane AB. Okay? So let it sink in. Parehas ba tayo nang nakuha sa calculators nyo? Check natin, ano? So we have 10,000 plus 4,000 all over 2 plus 10,000 minus 4,000 all over 2 times negative 7 over 25. So that is yung 6,160 PSI. And then, equivalent normal stress yan. So, kunin natin yung equivalent shear stress sa ating diagonal plane AB. We have the equation, shear stress is equal to negative stress x minus stress y all over 2 times sine 2 theta times shear xy times cosine 2 theta. Again, yung shear xy natin ay 0. Wala naman tayong nakalagay na shear dito sa ating stress element, so mag-zero out lang to. Ito lang kailangan natin i-consider itong left side natin, first term natin. So we have negative 10k minus 4k all over 2 times yung sine 2 theta natin na 24 over 25. So shear stress is equal to negative 2,880 psi. So this will now be yung equivalent shear stress natin for this particular problem. I mean, yung shear stress natin along plane AB. So, yan ang hinahanap sa problem natin. This will be yung mga sagot natin for this particular problem. And that is yung end ng ating discussion for principal stresses. So, mostly, sa ano lang siya, substitution ng mga given. Tapos, i-check mo kung ano yung mga be careful lang sa theta na gagamitin mo. Tapos, be careful lang din sa mga signs ng ating mga loadings. Ayan, and later on sa ating more circle, mas deep na yung natin yung discussion natin on stress transformation. But as of now, yun muna yung discussion natin for this particular topic. Do you have what questions do you have regarding the discussions regarding the topic para ma-address natin?